All right, let's get rolling. We've got 20 minutes in which I can give you a whirlwind tour through IE10, what's new in it, and what's new in JavaScript behind it. My name is Andrew Miadowicz. I'm the Senior Program Manager at Microsoft. I work on Chakra, the JavaScript engine behind IE10 and IE9. So you'll hear me talking about JavaScript primarily in this talk, even though it is about the browser as a whole as well. I hope this is what you came here to hear. Then you won't be disappointed. I am primarily in charge of JavaScript performance on Chakra, so anything from our JIT compiler through our internal type system to garbage collector. Those are all my domain, and I'm performance nerd through and through, so we'll talk about that quite a bit. But I want to give you a quick preview of the browser itself. You may know that in Windows 8, IE10 basically ships in two versions. There's the familiar desktop edition, as well as there's the Metro-style browser. Both browsers are built on the same core components. It's just that the Metro browser is optimized for touch and integrates with the rest of the Metro experience. So just to give you a quick show of what that's like, actually here, let's go to the Start menu. So this is the Windows 8 Start menu, and here's the IE. And just to give you a flavor, search works throughout Windows 8, works in the browser. So if I'm searching for, say, news, I'm being taken directly to my favorite search provider in the browser, and the rest works pretty much like you would expect, except that it's optimized for touch experience. So you might see that there's the app bar at the top and the bottom. The top shows me all the tabs. The bottom is the address bar and some of the other functions. So it is a fully functional browser with tab switching, but with a few additional features. For example, suppose I visited CNN frequently, I get to pin that site to my start screen directly from the browser. If I go now to my start screen, oops, if I touch it in the right place, my CNN is right there, and it'll take me directly to the browser. And you can tell that it's very much a Chromeless experience. It's content first. This is what I get to focus on most of the time. As a little extra bonus, if you look at the Bing, for example, if your website has a companion app that will come with Windows 8 App Store, we will showcase that for you so you can download that app to get the more tailored experience for your Windows 8 device. So that gives you an opportunity to sort of cross-brand between your browser, between the web app and the Windows app that you might have built. And gestures are available through and through. So let me find a better example. If we have some history, I can swipe across to go back and forth between the pages. So that's just the shortest possible introduction to the Metro browser. But if most of you, I assume, are developers, so you're probably less interested in the browser as the consumer product as you are in the browser as the developer platform. So let's go back to the slides. And one of the key things is the availability of the web standards. How rich is that platform in which you can build your web applications? And in IE9, we've gone a long way already to adopt as many W3C standards as possible. You see a broad range of those already there, from canvas and video through to geolocation and such. And we've introduced the concept of hardware acceleration, which some of our competitors have picked up on, such that some parts of your browsing experience are now fully accelerated by the GPU or can take advantage of multiple cores on your CPU and so forth. In IE10, we really doubled down on standard support. We've added no less than 33 additional standards, from things that allow you to lay out your applications more flexibly, from Flexbox and Grid, through CSS transitions animations, through web workers and WebSockets for building more responsive and more interactive and more connected applications. The stuff that is grayed out a little actually doesn't come across very strong on the screen there. Those are portions of the platform that are not hardware accelerated for various reasons. Typically, they just don't lend themselves to hardware acceleration. But we very much focus on hardware accelerating whatever can be done that way. We want you to be able to take advantage of all of the hardware that is sitting underneath your browser to build the best apps that you can. But that's about as much as I'm going to talk about the W3C standards. Most of the rest of the talk will focus on JavaScript because this is where I live primarily, and I know that it's important for you as well. So there are basically two aspects to JavaScript. There's standards compliance, there's ES5, and maybe in the future ES6, and there's performance. Those two go hand in hand. For me, performance is where I spend most of my time, but let's talk a little bit about the standards support. So we are still at ES5. ES5 was released roughly in the time frame that we were shipping IE9. We have implemented most of the standard in IE9 already. There hasn't been a new release of ECMAScript standard since then. The one element that was missing in the IE9 implementation was strict mode, which does give you the convenience of catching some of the common JavaScript pitfalls early. So we've added support for strict mode in IE10. And that essentially rounds out our support for ES5. But of course, the standard itself, it doesn't sit still. It continues to evolve. There are more proposals coming in almost monthly, it seems like, to the TC39 committee to be potentially added or at least considered for ECMAScript 6 or whatever the label is going to be attached to it in the end, which does present some challenges to implementing such standards. One of them is that most of them start as just very informal proposals that then get written up. Then some reference implementations emerge, but they often diverge on some details that may not be specified sufficiently or may have been omitted from the spec. So that's why we're collaborating with other browser vendors and others in the industry on a suite of tests that try to verify the compliance with the currently ECMAScript 5 spec, but you can imagine that will go forward into ES6 as well. And if you haven't been there before, I'm going to try to take us there. Let's see how it works. It's a suite of some 11,000 tests that basically test every little nuance and aspect of the ECMAScript compliance. And by now, most of the browsers are at 90+% compliance, which is very good for you as a developer. You basically can rely on your code doing what you expect to do across all the browsers. Now, the test takes a long while to run, so I won't show it to you. We won't be waiting for it all the way. I'm running currently on Windows 8 consumer preview, so that's our beta release. The RC is coming just in a few days, and if you ran this on IE10 RC, you'll see that we currently are right at 100%. All our test 62 tests pass. So as of now, we are the most JavaScript compliant browser there is in terms of ES5 anyway. And we're committed to making that standards compliance go forward as the standard evolves. So you can definitely count on us being there and being standards-based. Now, the other part of JavaScript is performance. And this is where my head is 95% of the time. So it might sound like a blasphemy if I say that actually JavaScript performance doesn't matter as much as you are led to believe. So on the spectrum of different applications that exists on the web today, the vast majority of them, the JavaScript performance as it existed as of IE9 was perfectly fine. In fact, most of them were not, any bottlenecks performance-wise were not in JavaScript alone. Most of the applications exercise other components of the browser, be it DOM, be it CSS, be it layout, be it canvas. All of them play a role. And it turns out, for real apps, JavaScript isn't as major of a component as you might believe if you follow the press. So basically, most of the performance of browsers is measured by JavaScript benchmarks today, but they focus only on the JavaScript runtime and basically omit all of the rest of the browser. So with the exception of perhaps HTML5 games and maybe some of the simulations, JavaScript isn't as critical, and basically performance is good enough already. But because there are those apps, and they continually emerge new applications of that kind that try to squeeze every little bit of performance out of the JavaScript runtime, this is where we focused our attention in IE10, and we'll continue doing so going forward. And to give you a little flavor, I've created a little demo that actually tries to mimic some of what the HTML5 games typically do. And I'll launch that demo in the traditional browser here. It's something of a preview. It's not currently yet available on the IE test drive site, but it will ship shortly after RC, and I would encourage you to check out all of the test drive site. There are many interesting demos there. But as this is playing around here, I'll kind of walk you through the internals of this demo. I call it Bubbles, and it's actually inspired by a bubble mark, a benchmark of sort created by Alexei Gavrilov in 2007. So there was a different time at the time. He was comparing performance of DHTML, as it was referred to at the time, to various RIA frameworks, so Silverlight, Flash, and such, in terms of performance of rendering and animations. So times have changed. At the time, he could run maybe 20, maybe 30 bubbles at full speed. Now he can run a whole bunch. And I've modified it significantly to emphasize some of the problems that HTML5 games deal with today. So at the core, of that demo, there's a small physics engine, which performs a bunch of floating point computations. And it is driven by a request animation frame. So about every 60 times a second, it gets a little ping, and then it updates the position of every single bubble, computes the collisions whenever the bubbles collide, changes the velocities, apply gravity, all these kinds of things. So a lot of floating point computations are happening there. Every one of those bubbles, or browser logos in this case, is a DOM element. It's an image that has a CSS transform applied to it. So it's centered around its origin. And then the inflation effect is achieved by scaling the image up and down as the bubbles move around. In JavaScript, every bubble is represented by an ES5 object, which has some getter and setter properties on it. So the updates are happening through getters and setters. And then behind the bubbles, that image that you see being revealed, that's a static image that has been covered by a canvas that starts off completely opaque white. And whenever the bubbles collide, we can kind of restart that process. Whenever the bubbles collide, there's a little blotch of transparency popped onto that canvas. And that's done by applying a Gaussian mask to the alpha channel of that canvas image. So again, a bunch of floating point math there. And if the browser supports typed arrays, the Gaussian mask is stored in a typed array. Otherwise, it's a traditional JavaScript array. And then, kind of last but not least, there's a touch surface on top. So if you have a touch-enabled browser, you can kind of chase the bubbles around with your fingers. You can't really see it on the screen, but I'm basically moving my fingers around. That applies sort of a anti-gravity field to the bubbles. And you can play with it by giving them more gravity, so they all drop down, or popping them all the way up. So it's kind of fun to play around. I've been watching that for hours recently. Great. So let's maybe pause that one now. So feel free to navigate to that link that I posted there before with your favorite browser at your leisure whenever you have the time, and see how your browser does. And when you do, pay attention not only to that big frame rate number, but also below there are two small numbers that you may not have seen because they're pretty small over there that actually give you an idea of how much time is spent computing every frame and how much time is spent rendering every frame. You might be surprised that the compute part, the part in JavaScript, is not nearly as big as you would expect. So that kind of confirms that point, that even for those apps, oftentimes JavaScript is not as much of a bottleneck. So what did we do in IE10 to help those types of apps run fast? We've done a bunch of things. And some of them were fairly fundamental. I kind of walk you through them pretty quickly. This is the behind-the-scenes kind of image of what's going on there. So you might know that in IE9, we already had a JIT compiler. So your code was first interpreted, and then as it became hot enough, we would JIT compile to machine code. But we did it only for x86, so for 32-bit Intel processors only. In IE10, we added x64 and ARM. So if you're running IE10 on your tablet device, Windows ARM tablet device, you get full machine code behind the scenes. We've also changed the approach we take to emitting machine code. In IE9, our JIT compiler was something of a conservative compiler. It would emit code that could deal with all the nooks and crannies of JavaScript. If you spend enough time in JavaScript, you know that you can do all kinds of weird things, adding numbers to strings and getting something. And our code would deal with all those different nooks and crannies by calling into the runtime to get some helper routines going. And that resulted in a fair amount of overhead. In IE10, we've changed that approach. We are now using profile-based JIT compiler that emits type-specialized code. Now, what does that mean? Profile-based means that as we run your code in the interpreter, we watch the input to every function and every expression that we compute. And then we store it in what we call a profile. For example, if a given function receives always integer numbers as input, we will keep that in mind when we then generate the code. The code that we'll emit is type specialized in the sense that it can handle only this kind of input, which means it's very tight and very fast, but if you feed it something else, it doesn't know what to do with it. So the flip side is we have to bail out if you give us different input than we expected. We jump back to the interpreter, interpret it for a little while, collect a little more information, change our assumptions, and then rejit the code with our new assumptions. So maybe now we know how to handle integers and floats, or integers and strings. It's a similar approach that other browsers are taking and just is represented under different names. So in Chrome, this approach is basically called crankshaft. In Firefox, it's their type inference engine. But we all roughly converge on a similar approach to JIT compilation. We added function inlining in IE10. And function inlining turns out to be a very fundamental optimization, not only because it reduces overhead of small functions, but it actually allows us to apply compiler optimizations across broader blocks of your code. So these things combined gave us a much faster math operations. So particularly for floating point numbers, we're much faster now than we were before. If you try to run the same demo in IE9, I currently can because I can't run IE9 on Windows 8, as I can't show you side by side. But if you do, you will see a big difference in terms of performance. With the type specialization, we don't have to allocate as many numbers on the heap. If you're familiar with the internals of JavaScript, you know that floating point numbers traditionally have to be allocated on the heap. We no longer have to do it. We can operate on registers directly. So big gains there. On 64-bit platforms, we employ float tagging, which eliminates the heap boxing altogether. And we give you typed arrays. Typed arrays also allow you to avoid heap boxing of floating point numbers. So if you do actually operate on big chunks of floating point numbers, do consider using typed arrays. That will give you a big advantage. It's something you have to opt into, but it's a very simple switch. We've made a bunch of changes to how we handle objects. It turns out that a lot of code written on the web today, it has some object-oriented flavor. So there are a lot of user-defined objects, a lot of property accesses, and so forth. We've made a bunch of changes there behind the scenes. We've changed how the objects themselves are laid out. In IE9, it used to be that every object had a header and then a slot array for properties. So we could accommodate expanding property numbers as you added more properties. But that meant for every allocation, every object created, we had to allocate 2 different chunks of memory. When we accessed the property, we had to do 2 memory dereferences. We had more register pressure and so forth. In IE10, we've optimized that away. We try to allocate just the right number of slots directly on the header. That reduces some of that overhead that we saw before. We give you faster polymorphic access to properties. Polymorphism is quite rampant in JavaScript. We're doing much better than we did in IE9. And we've optimized generally how we access properties. Oftentimes, you might access different properties of the same object in a row. In IE9, that resulted in us doing a type check for every one of those accesses. Now we've eliminated that. Effectively, we do one type check up front, and then every property access is just as fast as it would be in C++. So a lot of improvements there. And last but not least, we've made some changes in our garbage collector. We had a problem where for those animation-driven applications, we actually executed our garbage collections too frequently. We've changed the model a little bit to utilize some of the idle time between frames to do garbage collection. We actually reduced frequencies significantly, garbage collection frequency significantly. So that gave us a big performance gain there as well. And a few detailed things, we've added a separate space for leaf objects, so things like numbers and strings that never have references to other objects. They can be allocated in a different area, and our garbage collector doesn't have to grovel through them as it tries to collect garbage. And we have a fast path now for allocating numbers directly from the assembly code. So all these kind of conspire to give that demo the performance that you saw. Primarily the things about floating point numbers. For all these games, IE9 would not perform nearly as well as IE10 does. So big gains for really the types of apps that are pushing the JavaScript boundaries. And sort of as an icing on the cake, IE10 is a platform for web development, but it's more than that. Like you hear a lot about using web standards for building mobile applications. Most of that is accomplished with some kind of emulation layer or some kind of a wrapper like PhoneGap, where you might target iPhone or Android devices through PhoneGap by building on top of web standards. In Windows 8, we're going a step farther, and we actually allow you to build native Windows applications without any emulation layer directly using HTML, JavaScript, all the W3C standards. So essentially, the same components that power IE10 also power the native, quote-unquote, native platform for Windows 8 for building Metro applications. And just to prove to you that this is really true and that's very easy, it took me about 5 minutes to convert that demo that I showed you a moment ago to an app. I'm sure you would appreciate that little logo that I created. That is a full-fledged Windows 8 application. I've removed a couple of things that didn't make sense in the context of the application, but otherwise, it is what you would expect, so let me just show you. Let's see, am I going to be lucky or not? There we go, come on. Okay, what we're going to do is this. I'll kill the presentation because it seems to want to only exist in full screen. There. And now, let's do the weather app here. Come on, go, go, go. Doesn't work with me today. This is a beta, that's right, and there are still issues with it. But I'm not willing to give up. It's got to work. Well, it's not working with me. It's possible the resolution is just too low for it. Anyway, on the bigger resolution, I'll be able to dock this app side by side with another app, and you would see that just works like it did before. Touch works as it did before. I can play with the controls as I did before. So it's basically the same code that I grabbed. I plopped it directly into a simple Visual Studio template for creating a basic Windows 8 app. And with the exception of removing a couple of links that didn't make sense in this context, it just works. So if you want the same experience, you can have a native app built the same way. There's obviously a bunch of customizations that you can do on top of what you would do on the web, including things like the app bar that I showed you in IE. Every app can pop those types of things. So, but the starting point is trivial, and the effects are very nice. That's basically what I have. I think the last slide that I have is just a thank you. But I'll have to scan through all of them again. Here we go. So I will linger around. I believe we're out of time. But can we take a few questions, or is it time for the next one? Okay, let's take 2 questions, and I'll hang around afterwards. And also feel free to drop me a note at this email address. I think you were first over there.
It's fantastic that you're doing all of this with JavaScript performance. Do you have plans to address the actual slow problems like the COM-based DOM?
So our DOM is no longer COM-based, but I will say that it still has some way to go. And in IE10, we couldn't do it. We will definitely look into this in IE11.
What about WebGL?
Can't speak of that one either. Go ahead.
Has the debugger been improved at all? Visual Studio? No, the IE debugger.
So, yeah, so in the sense that it still runs in the interpreter, so you switch to the interpreted mode when you go to the debugger. What was the particular concern that you had?
Well, I mean, like, has the functionality changed for the new version of IE? Because as far as I know, the dev tools in IE9 are kind of the same as IE. I mean, where are they in the Metro browsing?
In the Metro browsing, you don't have the tools. You use Visual Studio to debug your applications. And you basically get the same debugging experience as any other language in Visual Studio. We've actually made quite a bit of improvements in terms of JavaScript in Visual Studio alone. I think you really appreciate the editor with IntelliSense and things like go to definition and those types of things, which I think are absent in most of the other JavaScript tooling. So for the Metro apps, you use Visual Studio for development and for debugging. In the desktop browser, you can use the F12 tools. We've made some improvements to them. They have not been dramatic. So it's an incremental improvement. But we're looking at that also in 9.11. Now, this was a couple of questions. I don't want to be... Well, there are like 3 or 4 others. I'll take them if I have the time. Can we do it? Okay, let's fire those 3 that were up in the hands were up in the air.
Will any of these performance or standards compliance improvements that we saw in IE10 be pushed back into either 9 or 8?
You can install IE10 on Windows 7. They will not be pushed back to IE9 as such, because it's just a bunch of new features that we added. Yeah.
Are you going to accelerate your deployment schedule to keep up with standards in other browsers?
There are no official word on that, so I can't really comment. We are considering that, but there's no official word one way or the other. But it's a good question. And last question.
So with the Metro, do you still have to gap to do device API, or is that one of the features that have been added in?
I missed part of the question. Would I still have to use the...
Device access through device API.
Oh, and of course, I forgot to repeat all the questions. So the question, the last one is whether I would still have to use PhoneGap to get to the device APIs. In fact, in addition to the W3C standards that you can use in the Metro apps, there's also the layer of native Windows WinRT, we call them, APIs that are directly going to the hardware layer. they are projected into JavaScript. So you can use them directly in JavaScript with JavaScript semantics and so forth. We take care of the translation layer for you. So it's better than PhoneGap. It's a native platform that is wrapped in JavaScript directly. Okay, so I apologize for not repeating all the questions for the recording. I think that's all the questions that we had. If there's anything else, I'll hang around. In the meantime, I'll hand over the mic. Thank you.
There we go. Are we on now? Excellent. So this is going to be quite a different presentation compared to Internet Explorer, being that we're a small startup in the mobile space. So actually, I was quite surprised as I was walking around, the conference here, as it's been going on, that not a lot of people actually know about Dolphin, or at least I got a lot of questions like, who is Dolphin? So Dolphin is, like I said, a mobile-only browser. So we're on Android and iOS platforms, launching on Android end of 2009. So think of G1 days. So really kind of the early Android devices really got good with, the technical crowd, the early adopters, and then got great traction coming into 2011, Series A funding here with the Sequoia and Matrix. And, excuse me, and then launching our iPhone end of last year. And then one of the bigger announcements for this year was actually bringing our voice commands into the browser. So you can envision Siri on an iPhone. We really brought that voice experience into the browser. So you can do all of your browser commands, go to websites, open up new tabs, really, drive the complexity out of the browser. So where others have started, with the standards, we started with the user experience. So really driving, usage scenarios, driving steps out of the process, and just making it a great experience overall. So some of the other features that we have, and I think some of the areas where we really utilize JavaScript most in-depthly is going to be our add-ons. So we have a pretty extensive usage of add-ons for Dolphin. So we're the first browser to bring add-ons to the mobile space. And I would say we work very heavily with partners. I work directly with our partners to bring those add-ons to the browser, to the consumers, to bring those services in. And we'll have additional announcements on that actually next month during Google I/O. So the question now is, what does Dolphin do with JavaScript? I mean, I think that, as I alluded to, we started out just on the UI layer. So if you think of, as a developer, and you want to target, our 16 million users for Dolphin, it's really going to be making sure you're hitting, for Android, we're using the underlying, Android WebKit engine. And then, of course, on iOS, you have, I would say the Apple complexity. So you have to use WebView on iOS. So, I mean, with that, it's how do you bring, your feature into Dolphin, I would say from the side, for expanded functionality above and beyond what you can do with the default browser in each case. So beyond that, last night I gave a Ignite talk on bookmarklets, which I found to be very important to the mobile space specifically. I wanted to ask the audience here at this time, actually, if there was interest from JavaScript developers to have that type of functionality inbuilt within the mobile browser. So I'd like to pose the question, hopefully get any response. And then I think Dolphin, if that's the case, I'd really like to push that for another Dolphin first and really drive it from a developer's perspective and drive that if there's demand, from that side of the equation. So you have also the consumer concerns and the developer concerns. So I'd really like to reach out and get your opinion on that. Beyond that, I think that mobile browsing, as a JavaScript developer, as a developer in general for the web, mobile browsing is really going to be front and center for the majority of the use cases going forward. I had mentioned in a previous talk, in the US, 30% of people are only accessing the web via mobile. So, and it's like 80% for some African and Asian countries, to where they're only accessing mobile or the internet via mobile. So when you're envisioning your apps, envisioning your services, you really need to take that mobile context into play, or keep it at the forefront of your thoughts, and make sure that you're testing and developing accordingly. So with that, like I said, if there's any desire to reach out to the Dolphin community to work with us for add-ons or additional features, we're always open for input and suggestions. You can reach me here. And if there's any questions in general about Dolphin, I am all ears, or even mobile browsing in general. Go ahead.
I'm sorry, I might be
Yeah.
ignorant on this.
Go.
I'm not sure why build a new browser and what you plan to, what's your revenue stream?
Yeah, so the question is, why build a new browser? I think that, like I said, as we started in 2009, there was no other browser except for the default browser on Android. So in our mind, it was bringing innovation from a UI standpoint. So we brought tab browsing, the gestures. At that time, when people thought of mobile development, they thought of iPhone only. So when you're an Android user, you really got a poor experience. So we were one of the first browsers to allow you to easily modify the user agent string with just a couple taps. So I would say that really got the ball moving. And like I said, it's all about bringing, I could say the same thing for the PC side. Why are there 4 or 5 separate PC browsers? It's really just tailoring to maybe a different usage scenario for the users, providing choice, providing different experiences. And then from a revenue standpoint, we are a startup, so we're actively engaged in different trials to monetize in different avenues. I think we always look to Firefox as an example on how to monetize as an independent browser, but that's always a work in progress. Yeah, go ahead.
Did you write the whole rendering engine yourself, or use something on the back end for that?
No, so the rendering is all underlying WebKit. So I would say it's a UI web view on top of both Android and iOS today. So as we get bigger, as we get a larger user base, and as we want to expand, I foresee us looking into that more deeply, as far as how do we differentiate ourselves from especially the stock browser. But as of today, it's the UI web view on top. Go ahead.
Are there plans to go into the desktop, maybe as a metro afterwards?
Yeah, so as today, we were mobile only, and I think that, as developers, I would say Windows Mobile 8 and the Metro make it makes it compelling. It's definitely something that we're looking at, just because, we of course stick to our mobile roots, but if it's then able to easily transfer over to the to the PC via Windows 8, that makes it compelling to look into. But nothing planned as of today. Go ahead.
What does Dolphin offer in terms of dev tools?
So dev tools, no additional dev tools on top, no. So like I said, from our side, since you should get the same experience, at least in the core website view, as you would in the default browser. So from our side, we haven't spent a lot of effort on the dev tools, but that is something that, now that I'm thinking about it, that would make for some interesting add-ons to just drag over and hit a dev tool and pop it up natively in the browser. So I can definitely get our team to look at that. That'd be great. Perfect. Oh, go ahead. Yeah.
How are your add-ons developed? What are they in? How do you make them?
Yeah, so currently the add-ons are mostly developed in-house. So they are a separate Android application. So they are Java predominantly, but they of course can run JavaScript when called. Excuse me. And all of the add-ons are then released on the Android market as separate applications, or able to be downloaded from within the browser as a separate app, and then we just have the signings to where they pull each other in. So it works very seamlessly on Android. On the iOS side, based on Apple restrictions, we're not able to utilize that. So no add-ons in the iOS space. Perfect. Yeah, go ahead.
Run into, I guess, pushback from users or just general issues on iOS, given that your UI web view on iOS is not jitted, whereas mobile
Right.
is kind of lock that down
Yeah.
themselves.
Yeah, from our user standpoint, we don't actually get a lot of complaints as far as performance. Actually, a lot of our comments are that we're faster, and I think that I think it's about the UI. Really, it's about, we have the tab bars at the top, so you don't have to maybe go into a menu to open up a new tab. So there's it's more about the experience. I think it really draws into the dynamics that it's not always about the technology, but it's really the whole package that provides the overall experience to the user. I mean, if it takes 15 milliseconds to render, but it took you 5 seconds to open up that window, then through the browser, then maybe you didn't get the best experience. Perfect. Anything else? Excellent. Thanks for the time, and look for more from Dolphin here pretty soon. Thank you.